Okay, so we've talked about the graphs of sine and cosine, which are by far the most important graphs for trig functions. However, we need to figure out these graphs for the other ones. So let's start with tangent. Okay, so let's make some observations or just remember some things about tangent to start with. First of all, tangent is sine of x over cosine of x, right? So one thing, let's think about cosine of x. Is cosine of x ever 0? It sure is, right? Cosine of x is 0 at pi halves and 3 pi halves. So that's something we're going to have to think about. Sometimes tangent is going to be divided by 0, which means it's going to be undefined. There's going to be some vertical asymptotes, okay, because we have cosine x here in the denominator. Okay, so that's the first thing to consider. Let's think about this next one before I tell you what this means. What does this mean? If we're finding tangent of negative x, we're thinking about if tangent is even or odd, right? We've talked about this a little bit. So tangent of negative x is sine of negative x over cosine of negative x. Sine is odd, so it's sine of negative x is negative sine of x. Cosine is even, so it's just cosine of x. So this is negative sine x over cosine x, which is negative tangent x. So what this means is, interpret this for me, tangent is odd, okay? So that's something else to keep in mind. It's going to have origin symmetry or rotational symmetry. All right, let's look at this unit circle with these the different values of tangent figured out here, right? So from your table that you're memorizing, you should know these few ones, right? Tangent of 0 is 0, square root of 3 over 3, 1, square root of 3, and then this is undefined, right? And we could find ratios to kind of plug in the rest of these values. So let's see, let's just think here, it's undefined here, right? Where the x values are 0, where cosine is 0. Sorry, not the x values, where the denominators are 0, right? Where cosine is 0. So it's undefined here and here. Okay. And let's look at this. So if we started here, we go undefined, square root of 3, 1, square root of 3 over 3, 0, square root of 3, negative square root of 3 over 3, negative 1, negative square root of 3. Here it's undefined. And then look what happens when we start here. Look at across the circle. Square root of 3, square root of 3. 1, 1. Square root of 3 over 3 matches. 0, 0. Match, match, match. Okay, so what this means is, what is the period if we start here and we start going around this circle? From here to here is pi, right? Look at this. This is going to be the same thing. So remember, cosine and sine have period 2 pi. Tangent has period 1 pi. It's different. Okay, sine and cosine is period 2 pi. Tangent is period pi. And we can kind of see where that comes from by looking at the values on the unit circle. So things we want to remember. Tangent is odd, it has period pi, and we have to be careful about where the denominator here is 0. All right, so let's look at, we're going to go from negative pi halves to pi halves. These are just the values straight from the unit circle, right? So starting at the bottom and going up, here's undefined, negative square root of 3 over negative square root of 3, negative 1, up to pi halves. Okay, so these are just the values here, starting at undefined, going around the circle this way. Okay, so starting at negative pi halves to pi halves. These should look familiar. Certainly these should look familiar from your chart. These we could figure out using reference angles if we needed to. All right, well, what happens here at these close to these undefined areas where there's vertical asymptotes? Let's look here as we get close to pi halves, right? Pi halves is close to 1.56. So as we get closer and closer to pi halves, our values are getting bigger and bigger, right? So that's a clue that this vertical asymptote is going to go up. And as we go the other direction, as we get closer and closer to negative pi halves, so negative 1.3, right? As our numbers get closer to negative pi halves, the values of our function of tangent are getting really negative. So this, it looks like as we get close to negative pi halves, it's going to go down, right? So up here, down here. Let's put it all together. Let me move me over. Here's what our graph is going to look like. Let's think about all the things we've talked about here. All right, so it has vertical asymptotes at negative pi halves and pi halves because it's undefined there, right? And just remember, these are the places where cosine is 0, right? And it goes up as it gets close to pi halves and down as it gets close to negative pi halves. It has symmetry about the origin, right? If we could either fold it twice and it would match up, or we could rotate it 180 degrees and it would match up, right? So those are the things we notice. And it has period pi, right? It goes from negative pi halves to pi halves. So period pi. So we could take a stamp of just this one little tangent thing, and we could stamp it going on forever in either direction, in every direction, in both directions, right? So this is what our tangent graph looks like. All right, so what about modifications? Okay, this is going to be very similar to sine or cosine. The stretching factor is A. We'll talk about that in a minute, right? So just a coefficient out front. This is different. Pay attention here. The period, so remember for sine or cosine, we had 2 pi divided by b. Now we have pi divided by b, okay? Because our period of tangent is pi. So this is the one different thing to pay attention to that's easy to get caught on. The domain is all real numbers except pi halves. And I mean, how that looks depends on what our period is, right? If we squish it or stretch it, wherever cosine would be 0, that's where it's undefined. But other than that, we can put on all real numbers. How about the range? So this is really different than sine or cosine as well. Let's just look, right? It goes down to negative infinity and up to infinity, right? Sine and cosine are limited. They just go from negative 1 to 1. But tangent goes from negative infinity to infinity for the range. So asymptotes occur at the same places as we're talking about here, where the domain. I think it's easier to think about this in particular cases and not in abstract formulas. And it's an odd function. Okay, so let's do some examples. Let's sketch a graph of one period of the function y equals 0.5 tan pi halves times x. Okay, so let's go to the dot cam. Great. And I'm going to move me to the side so I don't accidentally block stuff. Okay, and here's our function. So let's think about this. This is 0.5. All right, regular tangent, wouldn't have this 0.5 or this pi halves. So let's see our amplitude. In this case, we could call it a vertical stretch or vertical shrink is 1/2, right? Or 0.5, whichever way you want to say it. It's that coefficient out front. And now it looks like our period is a little bit different. So our period is going to, remember, be pi divided by this coefficient here, by pi halves. Okay, so we could say this is going to be pi over 1 times 2 over pi. Those cancel, and the period is 2. Okay, so let's put this together. It hasn't been shifted at all. So the period is 2, so it's going to be going from negative 1 to 1. It's still centered at 0, right? Okay, so we have vertical asymptotes here and here. Here's the one thing I want to mention about amplitude. So there's a term that I made up myself. This is a Miss Thompson special. I call them amplitude points, okay? And this is the case for a regular tangent function, halfway between the center, so like a quarter of the way along the graph, halfway between the center and the vertical asymptotes. So in this case, it's at 1/2 or negative 1/2 and 1/2. And whatever that quarter distance is, that's where our amplitude points are going to be. So our amplitude here is 1/2. Let's do negative 1/2. So halfway through, we're going to put these amplitude points in. Okay. In a regular tangent function, if it's not vertically stretched or shrunk, this would be at 1. Okay, halfway between, we have this value here is 1. Okay, so whatever our amplitude or vertical shrink is, that's our new amplitude point magnitude. Okay, so it's going to look like that. I'm just going to go all the way down and all the way up, right? And then we could take a stamp if we wanted to do another unit or another cycle. Here's 2, 3, Halfway between it would be down here. Halfway between it would be up here. And it looks like that. I'll tell you something that we don't do very often is do vertical shifts of these. I mean, you can, but it's kind of just getting ridiculous, to be honest. Tangent graphs are like not really used very often, except in trig classes. So that's a little secret. Sine and cosine, super important. You will use them forever if you go on in science or engineering. Tangent, I don't think so much. Okay, so we don't want to go overboard with crazy tangent functions just because we can, when we could always just graph them on Desmos, right? But we do want to have the main idea. Okay, so there we go, just like we did. And look, they put these little points in even though they don't tell you what they're called. So amplitude points is my little special turn of phrase. There we go, and it goes from -1 to 1. All right, let's do another one. Graph one period of y equals -2 tangent pi x plus pi minus 1. So let's go back. All right, let's graph a cycle of this. A few things to notice. We've got an amplitude and a reflection. And it looks like we have a horizontal shift as well. Ugh. And I just told you we don't have this very often, but here we do, a vertical shift. All right, this is like the works, the whole thing. So first thing I want to do, since we have a period change and a horizontal shift, I'm going to factor that out so we don't get confused. And I'm going to say pi times x plus 1 minus 1. Okay, so let's see, our amplitude is 2. There's a vertical reflection. There's a vertical shift of -1. What's our period? Our period is going to be pi divided by this, right? So pi divided by pi equals 1. So our period is 1. And our horizontal shift is 1 to the left. Whew, this is going to be a pain. We got everything here. All right, so let's think. First of all, where's our period going to be? So our initial period, so if it wasn't shifted, our period is 1, and it would go from -1/2 to 1/2, right? But it is shifted. It shifted 1 to the left. So it's going to go from -3/2 to -1/2. Let's say that's 1 or -1. It's going to go from here to here. Right? So we figured, the way we thought about that is we said, okay, the period is 1. So normally it would go from -1/2 to 1/2, centered around the origin. So here's our initial period. But it shifted to the left by 1. Okay, so here's our new period, -3/2 to -1/2. Right? All right, so we've kind of dealt with our period and a horizontal shift. How about amplitude? Okay, well, halfway between, normally, we would go and have this at 2 and -2, right? It would go like that. However, it's shifted down by 1, so we're going to go -3 to 1 for our amplitude points, and it's vertically reflected. So instead of going this way, it's going to go this way. So this one is going to be here at 1, and this one's going to be here at -3. All right, so we're taking into account our amplitude and our vertical reflection and our vertical shift. So let's not even worry about, so normally the center of this is at -1. So normally it would cross the x-axis there, but instead of crossing there, we've shifted it down by 1. So it's going to be right there. So we put that all together and pretend our line goes through the points. And there's our graph. This is a doozy, this problem. I probably would not put all of these together. Like I said, it's kind of like a little bit overkill. Somebody got really excited about tangent graphs and doesn't really warrant that much excitement. So let's take a look. Yep. Yes, we're at 1 and -1 for the amplitude points. The center is at -1, -1. We're going from -3/2 to -1/2. Okay, it matches the graph that we made. All right, what if we do it the other way? Let's find a formula for this function. So let's take a look. Tangent, centered at the origin, so no horizontal shifts. That's lovely. It's not vertically shifted at all. Also lovely. Not reflected. Terrific. So we just need to think about, okay, what's the amplitude and what is the period? Well, the amplitude we can see kind of from this graph is going to be 2, right? These amplitude points halfway between the center and the vertical asymptotes, here's 2, that value is 2. So our amplitude is going to be 2. And how about our period? Well, we can see our period goes from -4 to 4, so the whole period is 8. So pi divided by the period is going to be our b value, right? Normally we say the period is pi divided by b. It goes either way. So our b value is pi divided by 8. Okay. So we put that together. Here's our amplitude point. And our amplitude we figured out is 2. Which seems like they made it more difficult than it needed to be. Whatever, halfway between, whatever that value is, that's our amplitude. Okay, so we found our period and our amplitude just looking at the graph. All right, what about cotangent? Cotangent is even more obscure than tangent. Okay, this is like not in the scheme of like using math in practical ways, not that important. However, we're in trig, so we have to learn it. So let's observe a few things. Cotangent, remember, is 1 over tangent, right? So here's our tangent curve, our graph. So any place that tangent is 0, cotangent is going to be undefined, right? So let's see, it's 0 at 0 and pi. Sure enough, 0 and pi, there's asymptotes. How about where there's asymptotes here? Well, 1 divided by infinity is 0. So where there's asymptotes here at pi halves, here it's 0. Okay, so cotangent looks pretty similar, but it goes the other way, right? This goes up, well, I don't know which way on the video it's going to look, right? This starts low and goes high as you go from left to right. This one starts high and goes low. The period is still pi. So tangent goes from negative pi halves to pi halves. Cotangent goes from 0 to pi. Okay, so the periods are shifted, the same period, but it's shifted over. Okay, amplitude points work the same way. Figuring out the period works the same way. The range is everywhere except for where there's vertical asymptotes. So the domain is everywhere except where there's vertical asymptotes. Range is all real numbers, goes from negative infinity to infinity. And it is this even or odd? It's also odd. Okay, 1 over an odd function is going to be an odd function. All right, so let's graph one of these. So y equals 3 cotangent of 4x. Okay, 3 cotangent of 4x. So let's see, the amplitude is 3. The period is going to be pi divided by 4. Right? Pi divided by that number there. Okay. So here's pi fourths. We're going to go from 0 to pi fourths. There's one period. So halfway through is going to be pi over 8. And it's going to cross right there. Our amplitude is 3 and -3. So we're going to halfway from a quarter of the way across the period, we're going to be at 3 and -3, because remember, it starts high and goes low. Let's see if we match. Yep, 0 to pi fourths. Here's halfway through, pi eighths. Starts high, goes low. There we go. All right, let's do modified cotangent. This is painful, but let's do it. Here we are. They've got all the works here. Okay, so f of x equals 4 cotangent pi eighths x minus pi halves minus 2. It's the vertical shift that really just sends it over the edge. Okay. All right, first thing we have, it looks like we have a horizontal shift and a period change. So let's factor that out so we don't get confused. I'm going to factor whatever the coefficient of x is, that's what I factor out. So I'm going to factor out a pi eighths. So what is this? X minus 4? Yep. If I multiply this back out, I get pi eighths minus pi halves. So we're good. All right, so let's write down things so we don't get confused. Our amplitude's 4. There's no horizontal reflection or vertical reflection. That's a blessing. Our period is going to be pi divided by pi eighths. So 8. Okay, that's interesting. That's big. Our horizontal shift is going to be 4 to the right, because it's x minus 4. And this vertical shift, which I hate, is negative 2. We're going down 2. All right, let's deal with this. So normally for cotangent, we start at 0, we'd go over from 0 to 8. If our period is 8, it would be there. But we're shifting 4 to the right. So we're going to go from 4 all the way to 12. So let's draw that. Okay, cool. So we dealt with the period, we dealt with our horizontal shift. So now we got to do the vertical shift and the amplitude. So our vertical shift is, so normally we'd be here in the center, but we're going to shift down by 2. So here's the center of the graph, down by 2. And then our amplitude, we're going to go halfway through here. Between here is 6 and here's 10. So normally this would be up at 4, but we've shifted down by 2, so it's going to be at 2. And normally this would be at negative 4, but we're going to shift it down by 2, so it's at negative 6. Oops. That kind of looks like that. All right, I think we put it all together correctly. Let's take a look. I highly recommend maybe going back yourself and going through 1 or 2 of these just to make sure you know how to graph these. Yep, so we're going from 4 to 12. Our center point at 8 is shifted down by 2, and then we've got these little amplitude things halfway between. Okay, and that is tangent and cotangent.